Hi everyone, it's Math with AUB. Another question overlapping in several fields, linear analysis, number theory, as well as in discrete. Now, in these days, the question reads as if m is an odd integer, then 4 times m plus 1 is also odd. If m is odd integer, then we have to prove that 4m plus 1 is also odd. A very simple one, and we are asked to use direct method. We are also used to we are asked to use direct method. Direct method. Sorry for inconvenience. Yes. Okay. Let's prove m is odd. M is odd number can be written as 2 times any even integer plus 1, or m is tantamount to 2 times any integer negative 1, where p belongs to integers. Where p belongs to integers runs as 0 plus minus 1 plus minus 2 plus minus 3. Three dots shows the continuity, the standard continuity. Taking the first case, if m is equal to 2p plus 1, we have to prove that 4m plus 1 is odd. Plug in the value of m here. 4 times m is equal to 2p plus 1 plus 1. Tiny manipulation, 4 times 2, 8p plus 4 plus 1. 8 times p plus 4 plus 1. This part, if I take 2 common from here, any 2, 4 is also common, I am taking only 2 common. 4p plus 2 plus 1. Now look at this. It always give me an even integer, not odd. If p is odd or even, it will give me even. 4 times any integer plus 2. 4 times any integer plus 2 will give me even. Even multiplied by even always gives us even. Even times even and plus 1. Even times even, it's always even. And if we add 1 into even, it will become odd. It will become odd. If you have any doubt in that case about the value of p, let me elaborate both the conditions, whether p is even or p is odd. Here 2 times 4, p I am writing odd number plus 2, and here plus 1. 4 times any odd number, 4 times any odd number, 4 times any odd number, that's our 2 common. 4 times any odd number, 4 is even, 4 is even times odd plus 2, here plus 1. 4 is even. If suppose we have assumed that we have two possibilities for p, even or odd. P might be odd, p might be even integer. We are discussing both, and we have taken p is odd. Even times odd always gives us even. 2 times even times odd, even times odd. Take any values, even times odd always even. And 2 is also even, and 2 is also even. Even plus even, always even plus 1. 2 is also even, 2 times even is also even, or let me write 2 is even times even plus 1. Even times even, again even plus 1, even plus 1 is equal to odd. So we are at the safe side. 4m plus 4 times m plus 1 is odd whenever m is odd. Whenever m is odd. If m is given by 2p minus 1, the second possibility of odd, normally, we will arrive at the same result. Let's see and find out how. Here 4 times m plus 1. Now we are plugging in the value 2p minus 1 instead of m. 4 times 2p minus 1 plus 1. I multiplied 2 throughout in that case, or I multiply 4 times 2, 8p minus 4, and here I have plus 1. Taking 2 common or might be 4 common, I have 2 times p minus 1 plus 1. It's up to you. Take 2 common, 4 common, or even you cannot multiply 4. Here again we have two possibilities. P is odd, P might be even. P is an integer. P might be even, P might be odd. Okay, discussing first possibility. P is odd. 4 times 2 or P is odd number. Odd minus 1 plus 1. Odd minus 1, that's plus 1. 2 times odd, 2 times or odd. Let me write logically. 2 is even. Even times odd minus 1 plus 1. Even times odd, always even. Even times odd, always even. 4 times even minus 1 plus 1. Even minus 1 always results in odd. Even minus 1 always results in odd. 4 times odd plus 1. 4 times odd plus 1. 4 is even. Even times odd plus 1. Even times odd, always even. And if we add 1 into the even, it always results in odd. So our m is equal to p minus 1 is again odd whenever we have taken p is odd. P is odd. Now instead of odd, we are taking p as even. Here is the result 4 times m plus 1. Plug in the value of p, that m, that is 2 times p minus 1 plus 1. Now we have assumed that p is even. P is, in that case we have taken p odd. In that case we have taken p even. P as even. So we have 4, 2. P is even. 2 times even minus 1 plus 1. Okay, let's reconcile all the possibilities. 2 is even. 4 times even times an even number plus 1. 2 is even. I have written 2. I have written even. Even times even always results even. 4 times even minus 1 plus 1. If we subtract 1 from even, it always results odd. 4 times odd plus 1. Now 4 is even. Even times odd plus 1. Even times odd. Even times odd. Even times odd always results in even. If we add 1 into the even, it will always result odd. It will always result odd. So we have gently shown that if m is odd, then 4m plus 1 is also odd by taking both the possibilities of general notation for an odd integer, that is 2p plus 1, 2p minus 1, and so on. There are several possibilities. Even one can take 2p plus 3 or 2p minus 3. One can take 2p plus 5 or 2p minus 5. They all give us odd integer, odd integer. They are all general possibilities, general formulae, general notation, recursive notation for odd number. Thoroughly, these two are used, 2p plus 1 or 2p minus 1. It's my tiny effort, you guys, to explain to you how to play with numbers, whether they are even or odd. It's all by itself. Next.